Okay, in this example, we're going to look at how mechanical resonance and our understanding of that can help us decide at what frequency we need to push on a swing. So in this question, that's what it's asking: at what frequency must you push on a swing with a 2.10 meter long chain to keep increasing the amplitude of the person who is on the swing? And what happens if you push with a different frequency? So for the first part of this question, the key is that we're trying to increase the amplitude. So in order to increase the amplitude, the frequency at which we push is going to have to be equal to the frequency that is natural to the swing, the natural frequency of the swing. And we can calculate this natural frequency of the swing using the formula that we talked about earlier. And that formula is period is equal to 2 pi times the square root of length divided by acceleration of gravity. Remember, we can only use this formula if the angle is less than 10 degrees. So we're going to have to assume that the person on the swing is not going up to, 90 degrees. This isn't a crazy swing. We're just giving them a nice gentle swing, a nice gentle push. Let's look at what information we have. Well, 2.10 meters, our length is 2.10 meters. And also, since the question doesn't say otherwise, we're going to go ahead and assume that we are on the planet Earth, on the surface of the Earth, so our acceleration due to gravity is just going to be 9.81 meters per second squared. So we can calculate our frequency just by plugging these numbers into our formula. Is equal to 2 pi times the square root of 2.10 meters divided by 9.81 meters per second squared. And if we calculate this out, we find that we get a period of 2.91 seconds. So every 2.91 seconds, we're going to have to push in order to keep the person going and to keep increasing the amplitude. But that's not asking what the question is asking. It's asking what is the frequency. So remember, the frequency is equal to 1 over the period. We'll call this the natural frequency. So that's going to be 1 over 2.91 seconds. And if we calculate this, this is 0.34 with a unit of hertz is what we use for frequency. That's the same as 1 over seconds, remember. So the natural frequency of this swing is 0.34 hertz, and this is the same frequency that you must push at. If you were to push at a different frequency, if you push at any other frequency, push at any other frequency, what's going to happen to the amplitude? Well, the amplitude will not increase, assuming we're pushing at with the same amount of force. So that kind of answers the second part of the question here. The amplitude will not increase. So the person's not going to get any higher. So we were able to just answer this one by assuming that the forcing frequency had to be the same as the natural frequency. Then we can calculate that natural frequency just using our formula to calculate period.